So let's start with runtime exception classes. The runtime exception classes, they can be handled, but they don't have to be handled. The runtime exception classes, the exceptions from those classes, they can be thrown by a programmer or by Java virtual machine. So the first one is ArithmeticException. This is the one that is thrown when your code tries to divide by 0. Let's have a look on example. Let's create a class that is called ArithmeticException. So here I want to tell you something very interesting and important when you're naming your classes. So there are classes that are already predefined in Java. For example, our exception classes. So ArithmeticException is already a defined class in Java that is called when this exception happens. It means that if you will now create a class that has the same name, that is our ArithmeticException, so in this way, it means that you will overwrite the ArithmeticException that is already defined in Java. And you don't want to do this, definitely, so you cannot use the same name. I will call my code ArithmeticE01. So let's do what we don't have to do. To call this exception, we are declaring one integer answer, and we are doing the division by 0. And when we are calling this code, when we are executing the code, then we will receive here Java ArithmeticException in our console. So let's go in detail through this message here in our console. So first, this error message, it tells you that you have now an exception with keyword exception here. It tells you where. The exception happened in main class. Here, exactly, it is here inside of our main class. Then you have here Java language ArithmeticException. This is the name of exception that you encountered. And then usually afterwards, after the name of exception, you have some specific information, some extra information. And now it tells you that you are dividing by 0. So dividing is written here with a slash. Dividing by 0 is the error, the exception. Next, you can see where exactly this exception took place. So first you see E5 exceptions. This is the name of our package. Here, E5 exceptions. Next, you see the name of the class ArithmeticE01 here, and then you see the method. This is main method. So here, this part shows you the complete path to your exception. And here you have again the name of your class and the very last number. This is very important for you. This is the number of the line where the exception took place. So here number 7, and indeed this is the line number 7. So we'll save it and we will come back to our runtime exception classes. The next exception is ArrayIndexOutOfBoundsException. So this code is thrown when the code uses an illegal index to access an array. So let us create a class that is called index array index out of bounds exception. So I will just write E01 because I don't want to write exception as the whole words. Otherwise, I will overwrite the exception class itself. So actually, your name can be also different from this. Okay, I also clicked something else additionally with some information, but I will just take it now out, not to disturb you. So let's suppose that we have one array that is called counts of moves, and we are declaring it as an array that has 3 elements inside. And we want now to access some element of array that actually is not there in order to receive the exception that we want to see here. So we are accessing counts of moves, and since there is no negative array, no negative index of array, we are doing exactly this. That you don't have to do, because we're doing this because we want to see this exception. Here you see exception in thread main. Here you see the name of exception, Java language in ArrayIndexOutOfBoundsException, and you have here some extra information. You see here -1. This is what we have written here. This is this index -1 was the cause why this exception was thrown. We see here the path to our code where you have an exception. Why it is important? Because sometimes your program can contain several classes, as we have seen last exercise when we had several classes that were superclasses and subclasses of each other. Sometimes your subclass also inherits or also implements some other interfaces, so you can have a lot of classes in one package. And when you have only one main method within your program code, program class, and when you're executing this main method within your program class, you will not always you want to see in which, if you have an exception, you want to see in which class exactly this exception took place. That's why this path here is very important for those complicated cases when we have more than one class. Here you have in which exactly again the name of your code, and you see here the line. So you see that the exception was thrown because of something that happened within this line. So sometimes the message is not so helpful. So let's consider another example. Let's just copy this class and paste here. Exactly. So let's suppose that we have one more variable that is called total, and it equals to 0. And let us use the loop, the for loop, to add the values to our total variable. So integer e, we are doing first the initialization within the for loop. The condition is that e should be less than length of our counts of move array, length, and increment. So we want to add here with each run of the loop the elements inside. So why do we have an exception here? Let's come closer to our for loop. So the first run of the for loop, I is equal to 0. It's less than the length. The length is 3. So let us print out to the console somewhere here before. Let me just do in this way to show you what are the commented out. So now we see that length of our array, counts of moves, equals to 3. So let's now comment it back. So it runs till our I achieves number 3. Number 3 is still less or equals than the length of counts of moves. Yes, it's true. It is incrementing, and then this number 3 is written here inside. However, our third element, the last element of our array counts of moves, does not have the index 3, because this index is number 2. The index, since all the indices, they start with 0. That's why we have here our ArrayIndexOutOfBoundsException. So the next exception is ClassCastException. This exception is thrown when an attempt is made to cast an object to a class of which it is not an instance. So let us create a class that is called ClassCastException, just E01. And let's imagine that we have one string type that equals to moves. And then we are using our wrapper class. We will cover wrapper classes next exercise. So now I will just show you the type of exception that you could receive next time. However, we will not go in detail into wrapper classes for now. So integer, number, and we are doing now explicit cast integer, and we are trying to convert our string variable type into integer object. So you see here immediately some message from Eclipse that something here is not correct, so you cannot cast from string to integer. This is exactly what you're going to do. So in this way, Java tries to protect you from impossible casts. In this case, you want to cast from string data type, string object, to integer object. This is not possible. However, your code can be more complicated. For example, if you will add some object that is called type, and then you want to cast this object, so you just have one step additional in between this declaration and initialization of string object and this cast from string into integer. So you have just one additional step in between, and Eclipse already does not show you this message that something is not wrong. So when you will execute this code, then you will receive ClassCastException. And then you have very nice, actually very detailed message, extra information, Java language string class cannot be cast to integer class. And the error happened at line 9, so here, exactly. Our next exception is NullPointerException. This is thrown there when there is a null reference where an object is required. So let us create a class that is called NullPointerException. And let's suppose that we first have one static variable string that is called name. And then you have one method that is public static void print length. And you are using here the print statement. And we are using now the method length. Let's find it here in our list. So you just want to print the length of the variable name with the help of this method. And you are now trying to call this method print length. So it looks nice. Let's do it. And what do we have? We have NullPointerException. Why do we have NullPointerException? Because the instance variables and methods here, they must be called on the non-null reference. So it means that you should have initialized this variable and then you would not receive this message. So you also see on which lines the exception took place. So the first number 8 and then number 12. So actually the execution of the program starts always with our main method, and the first exception points to our print length method, and then we are going to the method, to the line where this method is already actually called. So it is called here, but it is written here, and this starts on the line 7 and exactly here, line number 8, where the exception takes place. The next exception is IllegalArgumentException. This one is thrown by the programmer to indicate that a method has been pathed an illegal or inappropriate argument. Let us create a class that is called IllegalArgumentException. Okay, so now we will define several methods. The first one is public static void set number of x. This method takes one variable integer data type with the name number, and we have one if statement if number is greater than 0, then number x equals to number. And we first write our variable, integer variable, number x. So this method, you now have to recognize this method. You see the name, the word set here. This is setter method. Setter method where that receives one integer when it is called, and then if this number is greater than 0, then the value of this number is assigned to the variable number of x. Let us also write a getter method, public static of integer type get number of x. Let's write that this is a getter, and we, in our getter methods, we have to return something, and now we are returning the value of the variable number of x. So in our method, we first want to set the number of x using our setter, and let's say that the user sets this number to negative value -2, and we want to print so let's first, and we are using here the getter to access the value. So actually first let's run the code with positive value, with 2. So first we're setting the number of x to 2 with using the setter method, and then we want to print the value of our variable number of x to the console using the getter method that we defined here. Let's execute the code, and we see number 2. Good. Let's put here -2. When we execute it, then we see 0. Why? Because the default value that is assigned to our number of x value when we declared it was 0. And then we have defined in our setter method the condition only if the number of x is greater than 0. Only then this number will be assigned to our number of x. So it works, this way of coding. So you don't handle in this way the exception. What you do, you're using here the if statement or some other control flow options to protect your program in some way from from users if they are putting some wrong inputs. However, sometimes you also want to tell the user that there is something wrong. So the first option would be, of course, to add here some print statement, if like printing here else, and if else would be the second condition that the number is less than 0, and then you could print something to the console like you have entered the negative number for number of x variable. However, this is not elegant version. This is not how you should deal with it, because the elegant option is to deal with it using exceptions. So let us rewrite the same code using exceptions. We will save this code and we will create a new one. We will copy the content of this one and we will name it 02 here. So now here in this setter method, we are doing it in another way. If the number less than 0, then we are throwing new illegal argument exception and we will put here the message to the user that number of x must not be negative, and in our else statement we are putting the number of x equals to number. So if this condition is false, if the number is greater than 0, then the value of the number is assigned to the number of x variable. And then let us leave here also -2. Let's execute our code and we see the first that your illegal argument exception is thrown. Now this is thrown by using the handling of exception by the programmer, and as this some extra information, you receive exactly the statement that you have written here inside as argument for illegal argument exception. You also see here the line 9 where the exception took place and line 20. This should be our main code exactly. So come back here. Let's come back here. This illegal argument exception, this is exception from runtime class, and this is usually thrown by the programmer. The NumberFormatException, the next exception, is subclass of illegal argument exception, and this is thrown when an attempt is made to convert a string to a numeric type, but the string doesn't have an appropriate format. So this is actually, you could also use a legal argument exception. However, this NumberFormatException was created since there are too many cases when when someone tries to convert string to a numeric type, so this additional class was created. So let us create a new class that is called NumberFormatException with the main method. And this exception is when methods are passed an invalid value. So let us write the integer parse int method ABC. So this is again the another class that we will talk about in our next exercise. How we will use it now here, just to show you the how this exception look like. So here, when we call this only one line code, actually, we see that NumberFormatException is thrown by Java virtual machine, and for input string ABC, this is the additional message that you receive for your information. So you understand that you can understand it as that ABC string is invalid string for this method. So now we are done with our runtime exception classes. Now let's talk about checked exceptions. So as you remember, the checked exceptions, they were here. They have in their hierarchy exception class. So these checked exceptions, they must be handled or declared. There are two most popular types of checked exceptions that we can just briefly go through, since we will handle them, those checked exceptions in more detail later. So the first one is input-output exception, and this one is thrown programmatically when there is a problem with reading or writing file. The second one is FileNotFoundException, and this is subclass of the first exception, and this is also thrown programmatically when code tries to reference a file that does not exist. So, as I have already said, both of those exceptions, they must be handled or declared by programmer. The next class is error class, and this error class has three classes of errors that we will consider in our exercise. The first one is ExceptionInInitializerError, then StackOverFlowError, and NoClassDefFoundError. All those error classes, they are also unchecked exceptions that extend the error class. And those error classes, they are thrown by Java virtual machine, and they don't have to be or must not be handled by programmer. The errors, they are usually rare, so you will not see them quite often. However, we'll go through those three classes. So now let us open our Eclipse and let us create a new class that is called ExceptionInInitializerError. ExceptionInInitializer E for us, and done. So first, let us write the code, and then we will discuss the error and the reasons why this error arises. So we are declaring now static block in this way. So now we declared some block that will have static content inside. And inside we are declaring integer array counts of moves as new integer with the length of 3. So you have already seen this code before, so I will just type it quickly. Counts of moves This one should be out. So when we execute this code, we see a Java exception has occurred. You have now an error that was thrown by Java Virtual Machine Launcher. When you click here, OK, you receive here the information: exception in thread main, ExceptionInInitializerError, caused by ArrayIndexOutOfBoundsException -1, and here you have your path and the line number 7. So when executed, you get this exception in initializer error because the error happened in a static initializer. That information alone wouldn't be particularly useful in fixing the problem. Therefore, the Java also tells you the original cause of the problem, and this is ArrayIndexOutOfBoundsException that you need to fix. So the exception in initializer error is an error because Java here failed to load the whole class, and this failure prevents Java from continuing. The next one is StackOverFlowError, and this error is thrown when a method calls it too many times. This is called infinite recursion because method typically calls itself without end. So let us create a class that will show you this error. Let's name it StackOverflowError. So actually the class before this exception initializer, this was error, this was not exception, it was, the name is error, sorry. So now let us open our Stack Overflow here. And let us write the following code. First, we will add here method public static void that doesn't return any value. Do not call this, since it will let you to error. The integer number, and now we are calling inside this method the same method again with argument 1, and in our main code we are calling the same again. So let us execute, and now you see you have here Stack Overflow. So actually your program crashed. Now you have multiple exceptions here, like one error and multiple nodes. So when Java calls methods, it puts the variables and the parameters and local variables on stack. And after Java does this here in this method many times, the stack runs out of the room and it overflows. So most of times this error, this Stack Overflow error, it happens when the method calls itself, and since the method calls itself, it never ends, and this kind of recursion is called infinite recursion. Let's save this, and the next class is NoClassDefFoundError. So actually we will not have an example for this class, since this error occurs when Java cannot find the class at runtime. It means that when Java was doing compile, the library was there. However, later, during the execution, the library disappeared. And then, in this case, you will receive no class definition found error. So now we are done with, let's come back here, with our recognizing exception classes part. So, why is it important to remember the exception classes? First, you must be able to differentiate between three types of exceptions: checked exceptions, unchecked exceptions, and errors. These types of exceptions, they have corresponding classes. So the checked exceptions classes, unchecked exceptions classes that are also called runtime exceptions, and errors. These three classes, the difference between them is that you have to remember is when you have to handle those exceptions, when you should not handle them at all, and when you may handle those exceptions. In our next part, we will talk about how to handle those exceptions.